All right, welcome to lab number 4, the final lab of the course. In this lab, we're going to take a look at how to work with command line tools with regards to handling GKE. And to start off with, we're supposed to use Cloud Shell. Let's just open that, make it a bit bigger. And the first thing that we need to do is deploy a GKE cluster. We're going to be doing that in auto mode. Just get rid of that. And we're first going to set up some shell variables to set up the region and the name of the cluster. These are given by the lab instructions. And then we create the cluster. So it's as simple as gcloud container clusters. So this is the GKE command. In there, we call the command create auto. That creates a cluster in auto mode. And we're going to name it based on what we set up previously. And we put it into the region of that we set up previously. As well. And this is it, right? So now we press enter. This is the first time we used an API, so we authorize shell. And then we basically wait for the cluster to deploy itself. All right, and now it's done. So basically what we can do is check from the console side whether or not we find that same cluster. And sure, it's here. It's the Autopilot Cluster 1 in Europe West 4. Perfect. All right. So next, what we're going to do is, as we're going to continue with the CLI, kubectl specifically, we're going to get credentials for it. So as you might know, kubectl uses credentials that are read from a file called config, which is in a subdirectory called .cube in your home directory. Now, we could create that configuration file ourselves, telling it about the IP address of the management layer, as well as how to authenticate against that. But this command from gcloud actually does that on our behalf. So we just run this, and now it has been created. So basically we can see that right now in our home directory under .cube, we're going to have a file called config that has everything in place. In reality, you might not want to show this publicly because this has keys in it. But for these purposes, once you're viewing this class, all of those clusters are already deleted. So we don't really care about you seeing these secrets here. Another way to view the kube configuration is to use kubectl itself, right? So if you call kubectl config view, especially because right now we only have a single context with a single cluster in it, we can just use this command directly and then see the configuration as a YAML file as well, right? And in this one, it's not actually showing you any of the keys, right? So you can see this, like this data omitted flag over here that restricts viewing sensitive information. So if you need to view your configuration and you're worried about showing the actual key values, then use config view instead. So the config view is a command that just works locally. So it actually reads through the file that we just saw and then uses that to give us information. If we want to know something about the cluster itself and whether it is accessible or not, we could use a command like cluster info. So you can see over here that this is giving us information about the control plane being running, a backend being run, kubedns being run, as well as the metrics server being run. So these are run by default when you create a GKE cluster. You can add additional plugins using command line options, but that's kind of past what we have time for in this course. Another thing we could do here in this shell is activate tab completion. So kubectl does support command completion in bash. So this way we can just use the tab key to fetch names of pods or clusters or whatever. It's fairly handy for administrative usage. All right. So what we're going to do next is we're going to deploy a pod, right? And we're going to do this just in a very imperative way. So we're going to create a deployment, and we're just going to say that the image that we want to have is nginx, and that we want to call the deployment nginx-1. And it has created that on our behalf, and we should be able to use kubectl get pods to slowly see that coming up, right? So currently our cluster doesn't have any runtime environments. So it takes a little while for the first pod to actually get initialized, as it first needs to create a virtual machine for it. But once we have one running, then creating additional pods should be fairly quick. Now it's creating the container, so now it has the runtime environment. Now it shouldn't take long. And now it's running. Okay, what we can do now is stuff like describe the pod. So now I'm using tab completion for describe pod, and I'm going to use the pod name and just going to use tab, right? So that's how cool tab completion is. It's giving us information about the pod itself, right? So we can see this is the node that is running on. So this is a node that was just created. Previously, when we looked at our cluster, we didn't have any nodes. And now if we refresh this view, we should be able to see that we actually got something running. Yeah, we got CPU. There we go. We got memory that's being used. Exactly. So yeah, we're slowly getting there. Take a look at the deployments here. Here is our nginx. Basic information. at the events. We have a replica set of 1. We can take a look at some logs. Right. Okay, so main thing is that it is running. So we have Nginx running, so that's a web server. Maybe we want to create a file for that, for it to distribute. So just gonna go like test HTML, and they say something like hello world, we are cool. All right, so now what we can do using kubectl copy is copy that test.html file to our pod. So this is our engine. Doesn't know how to complete that one, so I need to copy paste it from here. Like that. And then we kind of use the kind of SCP type of syntax here. So we say the host name or the pod name, colon, then the file, the file path. So we're going to put it into user share nginx HTML, and then test.html in there. So the user share nginx HTML directory is the default directory that Nginx is going to be using for serving content. There we go, we done that. Now, we still can't connect to the pod. We could from within our cluster using the IP address here. However, we can't do that from outside of the cluster. So what we need to do is create a service. And the easiest way to do that imperatively is to run the expose command. So expose pod, our pod name, we want to expose port 80, and then we want to make it a load balancer. In GKE, the type load balancer will actually create a cloud load balancer for that. So let's take a look. How that works. So when we created that, it created a service here, type load balancer, and it has a cluster IP, and it goes to port 80, and the node port here is 31204. You know what that means if you've used Kubernetes before. However, the external IP is not yet allocated, so it takes a while for the load balancer to be allocated, and then the external IP with that. So that's done now. So now what we can do is run a curl command onto that external IP, maybe using HTTP, right? And then fetch the test.html file from there. And that's the file that we just created. Another nice feature, if the metric server is installed, as it is with GKE by default, is using the kubectl top command. So this works similarly to the top command on the Linux operating system, but now we're just taking a look at our cluster. So if I say top pods, what I can see is how much CPU and how much memory each pod is taking on the cluster. Finally, let's take a look at at a introspection task. So for that, we first need to clone a GitHub repository that has some code for us. It's a fairly large repo, training data analyst. It's actually meant for data analyst training, as the name suggests. But it has happened to become a kind of a, default go-to for quite a lot of demos and labs. So we can use it for this lab as well. And we're just going to create a bit of a symbolic link to a subdirectory, make it easier for us to navigate there. And then if we go into Kubernetes, we have a subdirectory there called GKE shell, and that's where our stuff is. So there is a file here called new nginx pod. This is what it looks like, a pretty basic pod spec. So let's just create a pod based on that. So now we're doing this declaratively. So we're using apply from file new nginx pod.yaml. And now that pod has been created. So now if we use kubectl get pods, we're able to see 2 pods running. And note that deploying this pod didn't take as long as the first one, because now in GKE Autopilot, we already have 1 node running. So actually deploying a pod onto a running node is not really, doesn't really take that long, right? So it's just the creation of a virtual machine that takes time. One thing that we can do is we can connect to the pod. So basically the way that we do that is we want to execute a command in a pod, but we want to make that interactive, right? So instead of just running the command and then returning, we want the connections to stay open. And the command that we want to run is bin bash that happens to be available in this specific pod. And now you can see that we're inside the pod. We're as the user root. And what we could do here is all kinds of things. But because this is an nginx image, there aren't really that many tools available. So let's start up by updating some repos, and then maybe installing Nano here, right? Remember that any changes that we make here will not survive the evicting the pod, right? So if we make these changes, they're in the local file system, but when this pod gets scheduled onto a different node or even onto the same node, those changes will not survive, right? So now we installed Nano, and we could maybe take a look at that test HTML file that we uploaded previously. On this one, right? This is a new one. So let's create a new one. Hello world. This is really cool. And now this pod has that file, right? And now remember, this pod is only available in the local pod network. So how could we test whether or not the web page is actually working? Well, one thing that we could do is do something called port forwarding. So kubectl supports port forwarding. And what we want to do is forward our local port 10,081 to port 80 of the pod new nginx, like this. And that's what's going on now, right? So this is happening here in the foreground. So I'm going to open a new tab to then run curl. now I can run curl HTTP, and now I need to connect to the local host, so to the same machine that the kubectl port forward command is running on. And the port, as we designed previously, is 10,081. And then the HTML file I want to get from the pod was called test.html. And this works. So that's kind of one way to do testing of pod network internal services, even though we're not actually on the pod network ourselves. All right, so next up, let's take a look at logs. So just quickly, kubectl logs, the pod name was new nginx. And then we want to keep that open, and then we want timestamps to be available as well, right? So this is a ongoing stream of the logs of the previous created pod, right? And now if we retry getting that test.html, you can see that there's going to be a new line here referencing that. And then if we try to do something silly, like getting something that doesn't exist, it's going to be a 404 error, and it's going to be shown over here as well, right? So first of all, there's the 404 error, and then we also get the error from the actual nginx command. All right, that's it. Just a quick scratch of basics of how working with the CLI, or what working with the CLI looks like with GKE. I hope you enjoyed it, and see you again in your next lab. Till then.